good day, geometry. We are going back to some theorems involving triangles, but not triangle congruency. This time we'll be talking about triangle similarity. How can we prove that two triangles are similar? Which, Blake? Triangles that are similar means they are... what's the word that goes? Yes, proportional. Okay. So you might recognize a few of these acronyms, SSS and SAS, but instead of dealing with triangle congruency, now we're dealing with triangle similarity. The first one, the AA, angle similarity postulate, says that if two pairs of corresponding angles are congruent, then the triangles are similar. Oops. Oh, that's an R. There you go. Okay. If two pairs of corresponding angles are congruent, then the triangles are similar. Because we know that in similar triangles, in similar figures, the angles are still congruent, because in every triangle, no matter what the size, it has to have 180 degrees. You can have an equilateral triangle that's this big, all angles 60, or one that's that big. All angles will still be 60 because it's an equilateral triangle. So because of that, if you've got, we'll draw a triangle out like this, and a little smaller one, triangle out like that. Okay. If you know that two of the angles are congruent, two corresponding pairs, what theorem we've already talked about tells us the third pair also has to be congruent. This is kind of a sidebar to this. Why we don't need AAA, why we only need AA, is because we already have a theorem that tells us if we know two pairs of corresponding angles are congruent, the third pair has to be as well. What theorem is that? It was on your quiz on Wednesday. The third angles theorem, right? So we only need two of them, because if two of them are congruent, the third pair has to be as well. Okay, and the two triangles will be similar. Will be similar. So two congruent angles are all you need to prove that two triangles are similar. The side similarity theorem says that if the three pairs of corresponding sides are what? In our congruency theorem, if the three pairs of corresponding sides are congruent, then the triangles are congruent. In similarity, if the three pairs of corresponding sides are proportional, okay, then the triangles are similar. Okay? So it's an important distinction for side. Are we talking about congruency or similarity? If three pairs of corresponding sides are proportional, the triangles are similar. Okay? So for example, who's yapping back there? Joey, Blake, Shoosh. We've got a triangle here. We'll say this is 20. This looks to be about 10. This can be 25. Perfectly drawn a scale triangle. And then let's make one like this. Yeah. Okay, there we go. This is 20. This is 40. This is 50. Because we can use scale factor to show that the second triangle is twice the size, okay, of the first one. Those three pairs of corresponding sides are similar. They all have a similar scale factor, similar ratio. Then we know that they are similar figures. Okay. Question on that one? Okay. So the side angle side similarity theorem says that if two pairs of corresponding sides are proportional. Almost like congruent there. Are proportional, and the included angle is congruent, then the triangles are similar. Okay? For side, angle, side, we've got two things going on here. The two pairs of corresponding sides are proportional, okay? And the included angle is congruent. Then the two triangles are similar. So let's say we've got this going on here. We've got a triangle coming down like this, like this, like this, and like this, like this, like this. We'll say this is 9, say this is 12, we'll say this is 27, we'll say this is 36, and we know the included angle. The included angle means the one that's in between the sides that we're talking about here. Okay, that word included means it's a specific angle, not just any angle, the included angle, the one that's in between, that's formed by the sides that are proportional. These two figures would be congruent. Why is that included angle important? What theorem that we've talked about this year kind of explains why this included angle is important? Is it possible to have side lengths of 9 and 12 and 27 and 36 and not have that angle be congruent? Because of what theorem? What theorem explains why two side lengths, even though they're not changed, the lengths aren't changing, can have, Joe? Hinge theorem. Good, right? You could potentially have a triangle with side lengths of 9 and 12, like we have here, and a second triangle with side lengths of 9 and 12, right? But are those two triangles similar? No, because that included angle is not congruent. So don't forget about that. Okay, there is no just side-side similarity postulates. It's either side-side-side, all proportional, or side-angle-side with that included congruent angle. And the hinge theorem is the reason why we can't just use side-side. Okay? Questions on those? Ready to practice? Yes. Is this so much more fun than doing retakes anyway?
No.
Oh. Sorry. Okay. It says, for each of the three examples below, show how the two triangles are similar. First one, ABE and ACD. How are those two triangles similar? We can if it helps you to kind of split them apart, here's our top triangle. Here's triangle A, B, E. We know this is 52. And then here's our larger triangle. This is A, D, C. And this is 52 down here. But how can we say that those two triangles are similar? What can we use? Gino?
Angle similarity postulate.
Angle?
Oh yeah, angle.
How?
Because you have two pairs of corresponding angles.
I see one pair of corresponding angles with the 52. Where's the second pair? Blake?
Angle A, or angle DAC is going to be EAB.
Okay, so angle A, since these triangles overlap up here, they have an angle that they share, right? Angle A, or EAB, as Blake said, if we split the triangle apart, EAB is the same angle as DAC because in the figure, they share that angle. And what postulate or theorem tells us that angle A is going to be congruent to itself? Something congruent to itself. Joey? Reflexive property, right? Reflexive property. Because these two figures share an angle, obviously it's congruent to itself because of the reflexive property, right? And then the two angles that are marked here, right? That's our second pair of congruent angles. So these triangles are similar because of angle, angle. Okay. How about that second figure there? Again, talking about triangle ABE. I guess ABE for the first one. These two triangles here, ABC and DEC. How can we prove those two triangles are similar? And when you're doing some tests or for your homework, kind of run through your options, right? Your three options are either angle, angle, which means you need two pairs of congruent angles. Are we given any information about the angles here?
No.
So is angle, angle probably going to be the one we're going to use?
No.
No. Our other option, side, 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 which means we have to prove that all three pairs of corresponding sides are proportional. We're given information about two of the sides, but not the third. So side, side, side might be a problem as well. Our third option is side, angle, side. Oh, not 8. What am I doing? Side, angle, side, which requires two sides that are proportional and the included angle congruent. So we've got information about two sides here, right? We have 18 and 9 here and 15 and 30 here. What angles in the figure would represent the included angles here? Well, sorry?
C.
The angles formed by C, right? This one and this one. Even though we're not given measures for those angles, how do we know they're congruent? Nathan?
Vertical angle.
Because of vertical angles. Okay? So this is kind of be the one we're going to put our focus on here. We've got that included angle. That angle that is formed by the sides that we know. We know that's congruent because of vertical angles. We're now just left to decide whether or not those two sides are proportional. What do you think? Yay or nay, Peter?
Yes.
Why?
Because 18 divided by 2 is 9. 13 divided by 2 is 15.
Okay. So if you look at kind of Peter's making his proportion within each triangle separately, you said 18 divided by 2, but I'll go 18 divided by 9 equals 2, and 30 divided by 15 equals 2. Why is it 18 divided by 9 and 30 divided by 15? Why not 18 divided by 9 and 15 divided by 30?
No.
Why is it set up in that particular way? Because if I set this up as 15 divided by 30, then it's not going to be 2 and it's not going to be the same. How do I know that I can set it up in that order? Do you know? With corresponding sides, does the longest side of one triangle correspond with the longest side of another triangle if they are similar or congruent? Yeah? It's not congruent, obviously they're the same. But anyway, does the shortest side of a triangle correspond with the shortest side in a similar or congruent triangle? Yeah, right? So you know that the 18 and the 30, they go together because they're the two longer sides of what we have here. And you know the 9 and the 15 go together because they're the two shorter sides of what we have here. So you wouldn't set up 18 over 9 and 30 and 15 over 30 because then you're kind of crossing that. You're putting short with long and long with short. You want to put long side with long side, short side with short side. Okay. You can also kind of tell that this triangle is kind of rotated. Okay, to get to its position. If you rotate it back, you see the 30 and the 18, the 15 and the 9 match up. Right. The third one here. Find the value of x that makes triangle ABC similar to triangle DEF. So we are told that they are similar. We want them to be similar. We have to figure out the value for x that makes that happen. What thoughts do you have, Blake?
Figure out like proportion is AB to DE.
Okay.
And figure out what x needs to be to make it 1/3.
Yeah, let's find the scale factor here. Okay, and the only kind of pair of sides we can use to be successful to get that scale factor are the two sides that don't have any variables involved, right? The 4 and the 12. So just to keep our numbers whole, not have to deal with fractions, let's put our 12 up on top. 12 to 4 is simply equal to 3 to 1. Okay, our larger triangle is 3 times the size as the smaller one. Now that we know that, what does the value of 3x plus 1 have to equal for these triangles to be similar? Okay, 24, right? AC is 8. Our similar triangle with a scale factor of 3 to 1 would have to be 3 times that. So we multiply 8 by 3 to get 24, and we have an equation to solve here. What value for x makes that side equal to 24? Subtract 1 from both sides, divide by 3. We get a nice, fun fraction, 23 thirds. Ugh. Okay? But there we have it. Right? What would... Wait, is that right? That's not right. We're right or wrong? We're right or wrong?
We'll try plugging that in and see how.
Oh, I forgot parentheses. Parentheses, they matter, and here I was just, okay. All right, so now we've got 3x plus 3 equals 24. Subtract 3, divide by 3. Much nicer answer than 23 thirds. All right. And so what should we get for BC up here then? If we know that 18 is 3 times the length of BC, what should BC be? What should BC be? Should be 6, right? And if x is 7, does 7 minus 1 equal 6? Yes. Like we talked about before, the nice part about geometry is if you get an answer like 23 thirds, you're like, oh, okay, that's weird, but we'll just go with it for now. If you plug in 23 thirds for x in BC, you don't get 6, right? So you would know that your teacher immensely this day. All right. Questions on this? Do you know what you're looking for? Angle, angle. 2 pairs of congruent angles. Side, side, side. 3 pairs of proportional corresponding sides. Side, angle, side. 2 pairs of proportional sides and the congruent angle. Some practice with this. Let's look at page. It's a Friday, and you have 3 days.
But it's a Friday, so you should be kind of lenient, you know.
I will be lenient.
We are not getting the number game on Tuesday.
If you reduce the amount, I'll give us
If you reduce the amount of work, Joe will give us the
Page 384.
If you give us no homework, Joe will give you 3
9 through 13. And on page. There's no 0.
No, there is.
On page 392. 392, I would like you to do 5 through 8 and 10 through 12.
Bro, it's a weekend.
That's more than 9.
It is 5, 9,
I'll give you $4.
12 questions. You do 4 of them a day. You'll be done for 2
Or you
days.
just do 12.
It's going to snow 6 inches on Monday anyway, so if your parents
That's
want
not
you to
true.
go out and shovel, you're like,
That
oh,
is
I got
not
work.
true.
Academics first, Mom. Academics first.
No, my parents would just say get out.
No, then I have
6
to
inches of snow Monday. There's your homework. That's it, man. Have a good weekend.